Οι σπόνσορες.
Ένα introduction, ο Γιώργος, δεν κάνεις το introduction.
Ναι.
Εντάξει, καλώς ήρθατε, κτλ. Έτσι. Άμα θες πέρα, εγώ δεν έχω πρόβλημα. Ένα intro, θα καλέσουν τις
Αγγλικά. Τι?
έτσι, θες αγγλικά ή ελληνικά.
Αγγλικά δεν είπαμε.
Είπαμε αγγλικά.
Αλλά εντάξει, άμα θες ελληνικά, τι να σου πω.
Συνήθως,
Δεν έχω πρόβλημα.
δεν είχαμε πει αγγλικά.
Δεν θυμάμαι γιατί είχαμε πει.
Γιατί είχαμε αυτούς από το Telecomputeros, εδώ πέρα δεν είχαν έρθει σε event.
Και δεν ήρθανε.
Τώρα δεν βλέπω πολλούς, θα ρωτήσω.
Ωραία. Άμα είναι να μην είναι, θα τους ρωτήσουμε.
Ναι,
Άμα
ναι,
θέλουν
θα
να το
ρωτήσω
κάνουμε
εγώ.
σε ελληνικά.
Έχεις πρόβλημα?
Όχι, ρε. Απλά στα αγγλικά τώρα θα ήταν πιο εύκολο. Με ορολογίες και τέτοια, για να καθίσω να κάνω τώρα τις ορολογίες.
Το κάος είναι το ίδιο.
Το χάος είναι ένα.
Το χάος είναι
Το πεις καίος ή το πεις χάος. Πολύ καλό.
Υπάρχει κάποιος που μιλάει μόνο αγγλικά. Γιατί για να γίνει, να δούμε πώς θα γίνει η παρουσίαση. Αν μιλάει, γιατί υπάρχει και μιλάει μόνο αγγλικά. Εδώ ο διηγητής μας προφανώς δεν έχει πρόβλημα. Ήθελα να το κάνει στα αγγλικά, ήθελα να το κάνει στα αγγλικά. Αν δεν υπάρχει κάποιος που μιλάει μόνο αγγλικά, θα γίνει η παρουσίαση στα αγγλικά.
Ναι, το stream όμως είναι. Κατάλαβες, στο stream θα έχει θέμα γι' αυτό. Οπότε αγγλικά, εντάξει.
Οπότε αγγλικά.
Εγώ δεν μιλάω ακόμα.
Ναι.
Εμένα με έχεις από εδώ, έτσι δεν είναι?
Και τα δύο. Αυτό που είπε θες, το input είναι για την...
Α, οπότε και τα δύο θέλω. Έτσι. Γιατί δεν φαίνεται η ομιλία. Δεν φαίνεται η ομιλία. Λίγο πιο δυνατά.
δυνατά, πιο δυνατά.
Το φοβάσαι, μην το φοβάσαι.
Σας φοβά.
Όχι, όχι.
Και ήρθα λοιπόν να σας παρουσιάσω την ομάδα μας. Έχω παρουσιάσει κι άλλες φορές την ομάδα μας αυτό το Meetup, οπότε θα προσπαθήσω να κάνω συνοπτική παρουσίαση, γιατί τις άλλες φορές που έχω φύγει. Κάναμε μαζί του Γιάννη Papadakis παραπάνω. Και να σας πω μια καινούργια πληροφορία, οπότε θα πληροφορώ κυρίως εκεί. Η ομάδα μας ονομάζεται STSC, Software Testing Service Center. Και αυτά που θα ήθελα να σας παρουσιάσω σε σύνοψη είναι λίγα πράγματα για την εταιρεία, λίγα πράγματα για την ομάδα μας, λίγα πράγματα για το career development που μπορεί να έχει κανείς στην ομάδα μας, καθώς επίσης και για την εκπαίδευση που παρέχουμε. Δραστηριοποιούμαστε σε τρεις μεγάλες κατηγορίες πελατών, θα λέγαμε, οι οποίες είναι πολύ μεγάλες. Αυτές είναι η new institution, public sector και enterprise solution. Εδώ είναι ενδεικτικά κάποια από τους πελάτες μας. Δηλαδή, αυτή τη στιγμή μπορούμε να έχουμε και 500 πελάτες ενεργούς. Και εγώ προσωπικά είμαι leader για το τέταρτο μέσο στον Ιδρύο, που είναι ο πρώτος EU institution που βλέπετε. Σαπορτάρω το μέσο και στο EU Lisa, καθώς επίσης το EU Digital Wallet που δεν φαίνεται και το Frontex. Και στους τρεις κλάδους έχουμε άτομα από πολύ παλιά, γνωρίζουμε το business και έχουμε στήσει σε αυτούς τους οργανισμούς λύσεις εξατομικευμένες με βάση τον κάθε ένα από αυτούς ή ανάλογα με το τι θα ζητηθεί. Όσον αφορά την ομάδα μας,
Το άλλο θα μιλάς.
είμαστε μια ανεξάρτητη ομάδα, δηλαδή αν έχει κάποιος στην εταιρεία και πάει κάτω από ένα τελωνιακό project, δεν σημαίνει ότι θα είναι για πάντα στη τελωνία, η ομάδα διαχειρίζεται όλα τα έργα και δίνει ανάλογα με τις ανάγκες του έργου και ανάλογα με τα προσόντα του κάθε ατόμου και τα ενδιαφέροντα άτομα σε όλα τα έργα. Έχουμε μία αποστολή να κάνουμε improve το software quality. Έχουμε οι 210 αναγραφικοί άτομα, αλλά σύμφωνα με τις τελευταίες εξελίξεις πρέπει να είμαστε γύρω στους 250 και έχουμε και γύρω στις 40 νέες θέσεις ανοιχτές αυτή τη στιγμή. Το 45% των ατόμων είναι πιστοποιημένοι για το ISTQB, 87 διαφορετικά system under test από όχι applications, γιατί ένα από αυτά μπορεί να έχει και 10 applications κάτω. Οπότε κάθε από αυτά μπορεί να έχει και 34 διαφορετικά project products. Είμαστε 25 χρόνια ομάδα. Η director μας ήταν από τα πρώτα άτομα της εταιρείας. Ο manager μου ήταν πραγματικά ο πρώτος tester. Η director μας ήταν αυτή που ήρθε να τα ανακαταστήσει. Οπότε αυτοί όλα αυτά τα χρόνια έχουμε χτίσει αυτή την ομάδα και μας παρέχουν καθοδήγηση όλα αυτά τα χρόνια. Έχουμε 5 internal testing training προγράμματα και επίσης συντηρούμε σαν ομάδα ένα conference με παραπάνω από 3.100 σελίδες. Το οποίο το συντηρούμε εμείς για εμείς, γιατί πραγματικά στην ομάδα μας το ξέρουμε τι σχέδιο. Αυτό είναι ένα μότο που το ένιωσα από την αρχή που είχα σε αυτή την ομάδα. Όπως μπορείτε να φανταστείτε, επειδή είναι πολλά τα έργα και πολλοί πελάτες, το τεχνικό που χρησιμοποιούμε είναι αρκετά μεγάλο σε όλες τις κατηγορίες. Δεν θα το αναλύσω παραπάνω, γιατί έχω την επόμενη διαφάνεια που η προσέγγιση που ήθελα να κάνω σήμερα στην παρουσίαση ήταν να ζητήσω feedback από τη δικιά μου ομάδα. Είμαι λίγο που σας είπα 7 άτομα και τους είπα σήμερα το πρωί: δώστε μου σας παρακαλώ το feedback σας. Ποιοι είναι οι πιο βασικοί λόγοι για τους οποίους πρέπει να έρθει κανείς στην ομάδα μας. Οπότε, το πρώτο άτομο μου είπε ότι οι λόγοι για να έρθει κανείς στην ομάδα μας, να σας πω ότι εδώ πέρα η ομάδα μου έχει άτομα από πρακτική που ήρθαν αυτή την εβδομάδα, αλλά και από σύνολο άτομα που προέρχονται και για leader. Δηλαδή, ένας συνολικά leader πρέπει να είναι στην προγωγή. Οπότε, θα σας διαβάσω το feedback και κάπου εκεί, άμα δεν πάω το χρόνο σας παραπάνω, θα ρίξω και την παρουσίαση. Οπότε, η πρώτη κοπέλα μου είπε ότι οι λόγοι για να έρθει κανείς στην ομάδα μας, κατά την άποψή της, είναι η ποικιλία τεχνολογιών, τα project και το πολύ καλό κλίμα της ομάδας στη συνεργασία. Ο επόμενος, παρόλο που ζήτησα ένα, full tester, 5 meter. Γρήγορη επαγγελματική εξέλιξη, μεγάλο stack τεχνολογιών σε project, καινοτόμα έργα με ενσωμάτωση AI, blockchain, εξαιρετικό εργασιακό κλίμα και καλή επικοινωνία. Όσο και το AI, θα μιλήσω στην επόμενη παρουσίαση. Γιατί κάνουμε κάτι πολύ ενδιαφέρον που μου αρέσει πραγματικά. Αυτός που έγραψε το έξυπνο θα είναι τιμή του να σε έχουν ως leader. Αυτό τώρα έχω μισό με άλλο. Αυτό δεν ξέρω μήπως θέλει να έρθει εξ ολοκλήρου στη δουλειά του το λίγο αγίος. Επίσης, ο επόμενος λέει 5 είμαστε μια οικογένεια. Αυτός δεν ξέρω τι θα κάνει, ελπίζω να ξαναγεί. Ο επόμενος είπε, σχετικά με την ερώτηση, αυτά το πηγαίνει και εγώ στο μάθημα που εκεί κάτω. Σίγουρα θα έλεγε το περιβάλλον ότι είναι ο πιο σημαντικός λόγος. Όλοι είναι πολύ ευχαριστημένοι, ευγενικοί και πάντα εκεί για να βοηθήσουν. Σε βοηθάνε να ξεσκάσει από τη δουλειά και έχω βρει πολύ καλή παρέα. Αυτός είναι πάντα, μόνο με επαγγέλματα, δεν το αυτό. Ο επόμενος μου είπε, για μένα, όντως και ενώ στην δουλειά ομάδα, θα έλεγα ο πιο σημαντικός λόγος είναι το αναλυτικό περιεχόμενο εκπαίδευσης μαζί με τη βοήθεια που προσφέρουν και οι συνάδελφοι. Αυτό είναι ένα παιδί πρακτική που έχει εδώ και ένα μήνα. Ο επόμενος έχει έρθει εδώ και μία εβδομάδα και είπε ότι για τη συγκεκριμένη ομάδα δεν μπορώ να πω πολλά. Δεν έχω ακόμα τόση τριβή. Τόσο όσο αφορά το testing, έτσι όπως το αντιλήφθηκα και το διάφορο που έκανα, είναι μια δουλειά που έχει πρόσβαση σε πολλά tools, καθώς τα χρειάζεσαι για να βρεις αυτό που θες. Κάθε project είναι διαφορετικό, οπότε το κάνει τη δημιουργική δουλειά. Νιώθω πως θέλει στην κάθε περίπτωση παρόμοιο τρόπο σκέψης, αλλά και διαφορετική οπτική γωνία. Επίσης, πιστεύω ότι σαν δουλειά σε απαιτεί κάπως να είσαι οργανωμένος για να μπορείς να καταλήξεις κάπου σε έναν κώδικα, θα έχεις τόσες διαφορετικές περιπτώσεις και πρέπει να σημειώσεις να μην χαθείς. Συν ότι νιώθω ότι κάποιος έμπειρος τέστερ θα ξεκλειδώσει μια διαφορετική αντίληψη στο στήσιμο και την δημιουργία ιστοσελίδας, εφαρμογής κτλ. Οπότε ευχαριστώ πάρα πολύ την ομάδα μου για αυτό το feedback. Ελπίζω αν και σε εσάς λείπει κάτι από όλα αυτά, να έρθετε να με πείτε μετά να το συζητήσουμε. Για τους ρόλους έχω μιλήσει κι άλλη φορά, οπότε δεν θα επεκταθώ. Όπως επίσης και για τα training προγράμματα που είναι πάρα πολλά που τρέχω. Επίσης δεν θα επεκταθώ, αλλά άμα θέλετε μπορούμε να συζητήσουμε και μετά. Ευχαριστώ πάρα πολύ.
Ωραία. Ευχαριστώ πολύ για την αναφορά. Λοιπόν, τώρα θα αναφέρω και τους άλλους κωδικούς. Είναι σίγουρα η σκούφ, το έχουμε άλλο εδώ. Αλλά δεν έχει για τις εταιρείες προφανώς όσοι δεν ξέρουν πολύ παλιά εταιρεία που φέρασε στη Θεσσαλονίκη. Είναι η Τσάπ, έχω κάποιον από την Τσάπ εδώ. Ωραία, δεν θα κάνω παρουσίαση. Και η Τσάπ, πολύ μεγάλο τεχνολογικό center εδώ πέρα και μεγάλη επέκταση. Και μετά τους υπόλοιπους μετά το διάλογο. Οπότε τώρα ας ξεκινήσουμε στα αγγλικά μου σύνομα και ο Γιάννης θα μας κάνει ένα intro να παίξει την παρουσίαση. Ένα θερμό χειροκρότημα για τον Γιάννη Σπίρτσα από την Αθήνα.
Από την Αθήνα ήρθα, δεν ήρθα από πολύ μακριά, εντάξει. Το κάνουμε και αυτό. Πρέπει να φύγω από εδώ, μου φαίνεται. Θα πάρω και το λάπτοπ μαζί. Κάπως. I'm not showing this. I will switch to English now.
Okay. So, what do you expect it to show?
Okay, a second. Extend the display. Έχω κάνει extend. Μήπως είναι άλλη οθόνη. Τη δεύτερη. Κοιτάς τη δικιά μου τώρα, την πρώτη. Oh my god. I need to live away from this projector. Don't know how to do it, but maybe over here. Okay. Τυφρικές, αλλιώς, ναι, θα την ξανακάνω. Δεν ξανακάνω. Ναι. Ναι, για να είμαι λίγο πιο κεντρικά. Ποιο βλέπεις? Εγώ εδώ δεν βλέπω, ναι. Λοιπόν. Περίμενε λίγο. Ρε φίλε, τι το βλέπεις? Για κάποιο λόγο, σίγουρος. Οκ. Όπα, πάρ' το λίγο. Μιντζόν. Να κάνω κάτι που θέλω. Πήγε το ποντίκι τώρα πάλι. Cool. Okay. I'm okay now. I think you can hear me well, right? I can stay over here. So, who was in we test in Athens from here? Customers, a few people. Unfortunately, it will be the same if you are attending my workshop in WeTest. No? Only Stamatis then. Okay, we have one person. Okay, with Stamatis, we have done this in WeTest, but it's going to be a little bit more detailed, let's say, today. It will be more hands-on. I mean, you're going to interact with me a little bit. So before starting, who knows about chaos engineering? Even theoretical. What does it mean? What does it stand for? Anyone? No? So it's great. I think you will love it, hopefully. So a few things about me. I'm always saying this slide, it's in every conference I have been to. I haven't changed a bit. Maybe the company maybe I will change the company that I'm working in. It will change, but I'm Ioannis. I'm working as a director of quality assurance in GWI. I'm based in Athens, of course. I love everything that has to do with product and engineering. You know, we don't stick to QA. You know, nowadays QA is just a term. The umbrella of everything is engineering, so we love everything around engineering. I'm recently nominated as a Grafana champion. I'm a person I really love to advocate. I'm talking to international conferences as well, so it's really, you know, great to advocate, especially open source. So if you know Grafana, who is using Grafana stack in their company? Nice. Yeah, you will see some interesting stuff today. I love hiking and fishing, and I'm not this guy. At his age, I didn't go fishing and, you know, get some nice fish. You can find me there. I'm also an instructor for learning actors. I'm saying this because I'm working with these guys. You know, there are a lot of potential, you know, webinars and a lot of trainings. If you know learning actors, they are friends of mine, and they are doing a very good job in the training the community. So that's all for this, the intro. Let's talk about the talk today. We're going to see why reliability is hard. We'll start with some theoretical, hopefully I know it's Friday. I don't want you to get bored or anything, so we'll pass it very, very quickly. But you need to know the chaos engineering, especially some fundamental parts of it. The steep curve to chaos engineering. What does it mean? How do we shift engineering teams to know about chaos engineering, especially when it comes to chaos testing, like it's another layer in our testing process, and we need to know some few things about it, and how Grafana embraces chaos. So I'm here to sell Grafana. No, I'm going to talk about the open source of Grafana, but Grafana has done a lot. You know, I'm working as an ambassador for these guys. I see the community building really nice open source stuff around Grafana. So the others, if you don't know it, it's a monitoring visualization tool. It's just like other competitors like Dynatrace, you know, New Relic, you know, they are, but it's, you know, they are based a lot on the open source mostly. So reliability. What everyone says, it's really the most important features nowadays. We're going to see why. Why do you think reliability is, you know, very important for any company nowadays? Any guess? We're going to talk in the next slide. But anyone? Don't be afraid. I have some gifts after the workshop. So the people that interact with me the more, no, I'm kidding, you will get a lot of things. Okay, I think I will talk about this. What everyone thinks is reliability is hard. You know, they are building DevOps teams, SREs, platform engineers. You have seen all this, you know, area around the DevOps, how to build sustainable software. It's really hard. Why? Because in the modern world, we have a complex architecture. So if you see this machine, there are a lot of components, a lot of stuff operating, so a lot of point of failures. If something goes wrong, everything is falling apart. So complexity is really, really big. And another example, we have distributed systems. So you see here a bunch of microservices running on the backend. You have micro frontends. You know, you can split your application, the frontend layer as well, in different components. You have third-party providers. You have databases. Very, very complex. A lot of dependencies, a lot of point of failures. And they are really weekly tested. QA teams nowadays needs to be upskilled, right? You need to go through from the end-to-end functional testing, API testing. Okay, that's old. We need to see the bigger picture in this complicated world. So why reliability is hard? We have complex architectures, as I said. You have unexpected failure modes, and you have testing tools that are actually, you know, okay, there are testing tools we can use, but can we use them for specific things like how can I predict failure modes in my production environments? Have no illusion. Things will break, right? And the part of the chaos engineering today is to break the system. You shouldn't be afraid. I had recently a talk about doing the chaos experiments in production, and my CTO came to me when I sent a message, okay, tomorrow morning around 8 to 10, which is UK time because my company is UK based, we're going to run some chaos experiments in production, so maybe we'll bring down some servers. Yeah. Oh my God, he was searching around, who is this guy? He's the director of what? Of QA. Is he working in my company? So he was like, okay, yeah. Things will break. Of course, if you are doing these experiments in production, you need to work together with your DevOps teams. He was true. You need to have a policy, some testing procedures in order to make sure that everything is, you know, not affecting our end users, which are our clients. So the steep curve to chaos engineering, the first thing is they have a high adoption bar because we experimented in production, at least initially. And we cannot argue this principle, right? You are trying to predict failure modes on production, so the best thing is to test on production. Unfortunately, many organizations, as I said, even in my company, they weren't prepared how to test in production, right? How do we have do you have on-call engineers? Anyone in your companies? Like people that they are 24-hour support if everything goes wrong. I think you have, but maybe you don't know. One of the problems is the unpredictability. It's too complicated. If you do chaos testing in production, it's not very predictable what will affect. It will affect some customers, maybe we can scale and we are okay. You don't know exactly the experiment. So there are really, really complex ways of doing that. So the blast radius is hard to control. You have a lot of things to control, which is really difficult. Results are hard to reproduce, and the tools are not so well known in the community. So there is alternatives, and we're going to see one today. Shift left. Shift left is dead. I know a blog post written by a CTO in a security company, by the way. It says that, what is shift left? I mean, it's really dead. In a point of view, it's a matter of cultivating and changing the culture of your teams. So if your teams are okay to embrace the change, then the shift left will be a success story. If not, who's doing shift left testing? Success story, sorry. Developers are writing tests. You are consulting them. You don't do anything else, only consultants. Okay. If only we could, then the QA community will be less in number. And that's why the shift left, in my point of view, it's not like really successful, but at the same time, it should be, even in numbers. I mean, it shouldn't impact the QA community at all. We should embrace testing together with the teams that are actually developing things. So for chaos testing, the tool that we're going to see in this workshop today has to do how to shift left the testing in an earlier stage before deploying to production. We don't need a tool to do chaos testing in production. We need something really, really simple. So let's see this nice video.
Hired at Netflix in 2017,
Oh.
and my title was Chaos Engineer, and I was building a platform that allowed people to automatically inject failure into production without actually impacting the customer experience. You would create a failure, and the hypothesis was always like, I take this down, it won't impact these users, they'll have the same experience as these users, or you wouldn't run the test if you thought it was actually going to fail. But obviously sometimes we learned that it did fail, and they did have a bad experience in a Netflix. So we learned a lot about how our users use the system, but that learning ended up being confined to a team of 4 people I was on, and none of us were running production systems. We were making code to learn these kinds of things, so it became really important for us to educate people. And then I started thinking, well, the best education is going to be if they do it themselves. I shouldn't be running chaos experiments on search. It's going to be most useful if they can experience and see it.
So this nice person told us that the chaos engineering as a discipline started with the Netflix team, right? They are serving a lot of millions, or I don't know if it's billions, but it's for sure millions of users around the world. And they started a special team, the Chaos Monkey team. So you see a lot of different Chaos Monkey. By the way, the Chaos Monkey, it's a tool developed from Netflix team to do chaos engineering and chaos testing. So they split the teams. They had the Chaos Monkey team. I'm particularly proud about the Chaos Kong. They are dropping a full AWS region, so you understand what was their day-to-day activity. Just drop a server and see what's the outcome. Shut down an instance of one of our pods running in a cluster. Is it affecting our users? So the whole idea is that they split the teams to predict the unpredicted failures. So the technique that is introduced by chaos testing, it's called fault injection. What we are doing and we're going to do today, we're going to build Very simple microservices for the backend. If you set up the environment, it will be very quick. Hopefully you have done that. If not, we'll follow from the video later on. There is a README file in the repository which is very, if you follow it step by step, everything is fully self-explanatory and you will be able to run a chaos experiment very quickly. So fault injection is that you inject faults on your microservice architecture and you're trying to see what are the recovery mechanisms of your backend. Is it recovering fast? How fast? What's the latency? What is the throughput? How all this can be visualized through Grafana and any observability tool. Now, Nora and Casey, they are part of the chaos engineering team for Rally. So you see other companies very well known that they are building chaos engineering teams. So they are saying from the distributed system perspective, almost all interesting availability experiments can be driven by affecting latency or response types. What they are saying, in sense, is you don't need to kill an instance of a server. You don't need to bring down an entire region. You can just inject changes in the system and see how the system performs. There are some few facts, but I will go very quickly. According to studies, they are saying like 92% of the catastrophic system failures are results of incorrect handling of non-fatal errors. So you get a 500 request on your backend, something happens, a network maybe it's slow, you don't handle it, you don't handle these failures. So that's why this percentage is really big. And we're going to see the example today around this. Now, how hard is to improve? Some things here is just put a log printing statement or add some expressions in your code or fix me or to do. There are a lot of engineers that are very quick and fast and they want to deploy something really quickly. So are they writing unit tests in your companies? The fundamental. If they don't sit for chaos testing workshop. So there's no point. There is no hope. Chaos testing. So incorporate the principles of chaos engineering early into the development process. As soon as you develop, as soon as you commit or deploy a dev environment, you should be able to start chaos testing. So this is the whole thing of the shift left testing approach. So the principles of the chaos testing means incremental adoption. You start small, you pick up some areas, and then you grow big. It's application-centric. Chaos as code. We need developers and testers write chaos tests, right? And we need to have a controlled chaos, meaning that we need to have a correct procedure for the on-call engineers. How do we alert our teams? How do we use SLOs? Who knows what SLO is, by the way? What is? Tell us.
SLO is a term that used for big companies that get agreement with their customers. So it's for availability mostly. So the customers sign a contract with the company that says that the availability is 90.99%. That means that it's acceptable to the system to be down for 3 minutes a month. If it's more, they pay a fine. The company needs to pay a fine. This is wrong.
Not for big companies. I'm just adding that. Any company can do SLOs, but yeah, it's what John said. So you do an agreement with your engineering teams, with your product owners, with your customers. And that's why in the performance and the chaos world, the SLOs needs to be codified, like what sort of latency do you need to have in place. For example, I want this backend API. If it's the request duration is more than, I don't know, 5 seconds, just stop whatever you're doing. So you need to control chaos in a way you don't want to affect your customers, the usage in production, especially if you're running in production. This is the microservice architecture. We are not going to do the front end. This is for another workshop. We will focus on the backend, and we will build this with Go. They are predefined. The Go microservices are there in the code repo. You don't need to know Go to develop something. I will explain some things, but it will be really fast. And we're going to use K6. Who knows K6? I'm selling this K6 on Grafana. I need to take some money from them. I don't know. I'm not good as a selling point, but yeah. So K6 is a performance tool initially. They were bought from Grafana. We're going to talk in the next slide. So we need to embrace failures before going there as normal. So if you see your system failing, it's normal, but you need to build your SLOs in order to prevent failure modes in production. So Grafana K6 is the best developer experience. It's not my words. I'm not selling this pitch today, but yeah, it's a very cool experience. I have been working with Grafanistas guys and you know, the community for so long. Like, it's really great. Why K6? It's open source. It's programmable. It's performant. It's written in Go, so it's super fast. It's extensible. You can build your own extensions. And there is a lot of documentation. There is Slack channels, community, lots of people talking about this. Really, it's really great. So let's start the fun now. I think we passed 20 minutes of theory, and I'm going to break after the long trip of coming here. So hopefully you can scan this. You have already the repo? I think there were instructions how to download. Just clone the repository. And a few words before starting. We're going to use a tool which is an extension from K6. It's called XK6 Disruptor. This is actually an extension to inject failures. This is what we're trying to do today, right? We're trying to do fault injection to the system. And there are two types of disruptors. Who knows how a Kubernetes cluster operates? Even a little bit. How it operates? A little bit. So the cluster has its own mechanism to do recovery. You know, if a pod is down, which is running parts of your application, it has a way to scale on its own. So someone would say, you know, they have a recovery mechanism already. So they have two disruptors. The first one is the pod disruptor. You see here it's the test script. Oh my God. Here it is. This is our test case, right? And we are using the pod disruptor to inject failures. What it's doing, it's attaching. Oh my God. I'm an old guy. Okay, so what it's doing, think your microservice is running on one pod of your cluster, another service is running maybe on another pod of your cluster. It's injecting failures within the pods, attaching an agent. The agent lives within the pod, actually within the container that runs inside the pod. So this is the known pod disruptor. I will tell the steps because we're going to run a Kahoot game in the end. The lucky 3 winners will take some nice gifts, t-shirts from Grafana and this one. Okay. The Grafana, they told me, okay, you can, and maybe from learning characters, they said like, because they are giving us the Kahoot, so they can send some nice gifts. So the pod disruptor, what it's doing, selects the pods based on some labels, and then they are attaching the agent. And then they inject the fault, sending a command actually within the agent. The service disruptor, which is the second one, it's like a wrapper for the pod disruptor, which targets the pods that are backing a service. Previously, we didn't see the service, but the app containers. Here you see the service pods. That's the difference. But you see also it's running the steps like the normal pod disruptor is doing. It's using the definition of the service, and they create a pod selector, and then it's attaching an agent within the service pods, and the other steps are the same as we discussed earlier. So there will be questions around this. I give you hints about the Kahoot. And what you do next, it's very simple. You just use the disruptor, you run the tests in your service and see what's happening on your backend. Okay, I think we are far, and I need to open the VS Code now. Let's do the example together, but I need to change my screen. Give me a second. Mirror. Cool. Who is having Docker? Oh my God, Docker engine. Download it based on, you have it. All right, open it. Open the Docker engine. So the Docker engine, we need to actually build the services and deploy them directly. So before going next, we're going to build two microservices. One will be here, the consumer, and one the provider. I'm showing this here. So you have one for the consumer, one for the provider. They are having some files like the mod and the sum. Who know about Go or written some few or hello world or anything? Experimented in Go? Nothing? We are testers, right? We don't have developers here. I'm in the wrong workshop, no, I'm kidding. It's black humor. I mean, it's very simple, I will tell you. So the Go mod and some files are the files that are defining the dependencies to run the Go microservice. So the main implementation of the service is the main.go. If we open, let's start, for example, the provider. By the way, 1 second to open the README. What do you see here? Okay. So let's start with setting up the cluster, these steps. So we have Git, we have Docker Engine, kubectl. You installed it? People? Cool. And have an account on Docker Hub, because we need to deploy the images. So, Docker Hub, if I place Docker Hub, and you go to the first link, hub.docker.com, I can do a sign in. I have my credentials, but I need you to sign in on the Docker Hub because we're going to deploy these two microservices. The one is the consumer chaos, one is the provider. So these they are going to run within the pods of our cluster. One is consuming the other. That's the name of, that's how we're using them. So we'll build a time API, timestamp, with one, and the other will call it to get the timestamp. I hope you have both of them. And you have Minikube. So Minikube, it's an installation to build a Kubernetes cluster in your local dev environment. Who download? I think it's all part of the exam of the guidelines, but if you didn't do that, it's good to participate. So these are the steps. You can pick any version here of the releases, maybe pick the latest one, that's fine. And if you need help, and go around a little bit, you can stop me, because sometimes I'm speaking too much, and I think, I hope you can follow me. So if you downloaded Minikube, just open your terminal, go to VS Code, open your terminal, and run Minikube start. Minikube start. So what it will do, it will start a Kubernetes cluster in the local environment. Don't close this terminal that you started it. You'll see some stuff here. It's downloading on Docker. I think it's not closing, that's fine. It's using an image of Kubernetes Minikube, storage provisioner, version 5, that's fine. I mean, if you are using the latest, you don't have to worry about which version is running. Now, if we started our Minikube and go to Docker desktop, you will see in the containers, one container running the Minikube over here. Let's go back. Have you seen that? Cool. So it means you have a Kubernetes cluster running on your environment. That's the first step, let's say. Now, then we need to build our service. Before going there, let's go and start with the provider service. So, a few things about the service, and then we can build it together. Oh my, 1 second. So, if you have seen this, I know that you don't know Go, but I will explain it very quickly. The Go microservice has a definition within the main Go, a function actually, which is the main. It's like in Java static void main, right? It's an entry point for the service to run. So what we're using, it's the Gene, which is a library, it's a framework. It's a web framework. You can create one endpoint, actually one web service, that it's running on the port 3000. So what we are doing here is that when you are doing an API call, a GET request to the service, it will return 200 OK. You see that here. And it's running also a current time in your output. So you'll see what's the time in, I think it's a Unix format. Yes, it's on Unix format. So we're going to build it, deploy it on Kubernetes cluster, and we're making a very quick API call to see that the service is up and running. Now, before going there, let's see some other files. We have the Docker file. The Docker file needed to build the image and deploy it. A Kubernetes cluster is working with Docker containers. That's why we are building Docker images for the services. Otherwise, we shouldn't. So the Docker file, we are using, have you used Docker before? Created some, okay. So we have some familiarity. We're using an official image, which is a Golang Alpine. We need an image that has a pre-installed version of Go. What we do there, it's pretty simple. We set the work directory, we copy files inside the container, actually the mod and the sum, and then we are running the download to actually download all the dependencies for the microservice within the container. And then we are copying also the main implementation of the Go file that runs the web service. And we build it, and we have an entry point, which is the command /main, which is the main function of the web service. What we did is we built, with this Docker file, a fully operational web service that can run on our cluster. Now, we have another two files. The first is the deployment YAML. The deployment YAML is telling the configuration for cluster what to do with this service, how it's going to use to run pods, right? How it's going to bring it up. So first thing is that we're using 5 replicas, meaning that it will start 5 pods running your service. Why? Because as we said, there is a mechanism Kubernetes to self-heal. If one pod goes down, we have another 4, right? So it's pretty nice. We have some labels. This is the consumer chaos label. It's labeling, though, the pods, how they are going to be shown if you start your cluster. You don't have to know all the deployment YAML attributes. Everything is, predefined. We just discuss it. Now, in your environment, in the specs, we are saying which image it's going to use to download the Docker container and run within the pod. So here, you should place your username in Docker Hub, like mine. I have gpub84. 1984, so I'm 40 years old. Thank you. I think you understood that already. So this needs to be replaced with your username on Docker Hub / the consumer chaos. So what we are telling to the cluster is just to pull this image from Docker Hub. And another thing is the secret ref, right? How it's going to connect to Docker Hub, the Kubernetes cluster? They need to have a password, right? We don't have hard-coded passwords on deployment YAML files. It's a security policy. What we're going to do now is, later on, we're going to install and create this secret. So you need to pass your password and create a secret for the cluster to connect to Docker Hub. And the others are pretty much the same. We have a container port, which is 3000. Cool. So without any delay, I think we missed the service YAML, which is the definition of the service now. So Minikube, it's not coming with a load balancer. Do you know what load balancer is? We have somewhere. Okay. So we need to expose the port is 3000 is running within the cluster. The cluster is a virtual environment, right? It's running pods, but you cannot access them. So you need to set up a load balancer, set the port and the target port, meaning that you are going to expose the port that it's running your service outside of the cluster, because we need to reach the microservice, the web service. And that's the service YAML. Now, let's start the cool stuff. Let's go to the provider, and I will open my notes because I don't remember everything correctly. Let's go to the provider, and let's build the service. So what I want you to do is to copy this. Why are you going always over here? I have this. So copy this command to build the image for the provider. Okay? You need to change your Docker Hub account. So if I do that together, do you need help? Just stop me. I'm coming over. Or Ioannis. So just run docker build -t, and actually the provider chaos. Okay. No. Cool. Okay. So provider chaos and dot. So what you are going to do now, let's increase a little bit. It's not very. Yes. Docker build, you are getting what? I will check it. I don't know. Can I pass through? Sorry, guys.
So the command is docker build, And the error is
Yeah,
Docker build X.
Yeah, I think, where is that? You need to pass this.
Ah,
File to
okay.
resolve, open Docker file, no such file. You need to go within the providers, right?
Okay.
And this is here it's the Docker file. Now it's working, all right? Yeah, I think I haven't said that you need to go within the provider folder, the folder that has the Docker file in order to build the image. So don't do it on the home directory. Go to inside the provider from your workspace and run Docker build. So the steps are the steps of the Docker file, right? The work dir, I'm copying the dependency files, I'm running. Of course, you will see cast here because I run multiple times the Docker file in my environment. So each time that all the steps are cast, if there are no changes in your Docker file. And then it's building the image. We are done, yes, but you need to push the image on Docker Hub. So the next thing is just run Docker and push. I will put it here. Where is that? Sorry guys, before doing that, yes, let's push the image first. So this is the command, copy this command from here, Docker push, all right? If you haven't done Docker login, because you need to push the image on Docker Hub, the first time it will request credentials from you. I have saved my credentials, so you need to do Docker login before pushing the image, and then we're going to use Docker push, all right? So if you have done your Docker login, then we can actually run and push the image. So you will see here, it's pushing the image to Docker Hub. That's it. We're done. We have our service packed and created the container and an image for this service. All right? So if I go back, we need to create the secrets. I have done this already in my environment. If you deploy your service, what I need you to do is copy this section, kubectl, create secret, Docker registry. This is the secret name we have set on the deployment YAML file. And we set the Docker Hub username, the password, and the email. If you run it, you create a secret on Kubernetes cluster to connect, as we said, on Docker Hub in order to pull the images from there. If you do it, you should see secret, Docker Hub secret created. I think it will be, if anyone is not following, you can reach me on LinkedIn or whatever. We can share some information. If you find any problems reading the README, I think it shouldn't be. I mean, it's pretty quick and nice. And now we are ready. Yes. Yeah, that's fine. Yeah. Yeah, it's okay. You mean with Google account?
You sign up with Google account.
Oh, really? I think I need to. I don't have I don't have an answer with the G account. We can wait for a while. Yep.
Yeah, I need to connect to the
There is one. Okay.
the desk. Request access to...
Yeah, you didn't say you need θέλει το Docker Hub account σου εδώ.
Να, οπότε... Το βρω αυτό.
Για πες εδώ. My profile. Account settings. You have time, you know, outside of this workshop. So if the quick guys can quickly move on. So let's do the kubectl apply. So what the next command I want you to do is to copy this command to deploy the provider microservice. First, we need to apply the deployment YAML and then the service YAML. But before doing that, you start in a new command, the Minikube tunnel, because as I said, the Minikube is not coming with a load balancer. You need to tunnel requests outside of your cluster, and that's why we create tunnel. So what I'm going to do, let's go to one terminal that I have created here and use Minikube tunnel. In the first time, you are not going to see these two log outputs because I have already the services deployed in my environment. You shouldn't see anything. But you should start, it should start the tunnel, by the way. So let's do the deployment. kubectl -chef apply and pick the deployment YAML. Sorry, I think I made it wrong. Chef. Yes, you will see in my environment it says unchanged, the provider chaos. In yours, it will say created the first time, right? This is because I run it multiple times. And then the rest, it's a little bit quick. We run the service YAML. Sorry, one mistake from me. Okay. Service YAML, and you should create the service YAML as well. Now, if I run kubectl get node, I see the Minikube running. If I run the get service, you should be seeing the provider chaos service running, which is top load balancer. You will see some IPs, the local IP, and the port that it's running. So just run kubectl get service to see the service that it's running for the provider. Now, we can test the provider. The main implementation, as we said, it's a get request, right? So you can do a call command with a location. You can place the IP if you like. I don't remember if I ran. Minikube is running, the provider is running. I have run it, but I don't remember when. The last time. It's been a while. Yeah. Oh, yeah, sorry, I didn't put the port. So you need to put in the curl command the port, HTTP, localhost, or the local IP. And the port 3001, we created a port that we can access the service outside of the cluster. And the output is this one. So you see here, we have current time in Unix format. You get the current time. Everything is good. The microservice is up and running. Now I want you to do the same without any delay. Do the same on the consumer. I have built already, but go outside, go to the consumer directory, and there are the same steps: build, push the image, and deploy the service. I will give like a few minutes. I will do it also here to just see it. We just build with the name, and then we use consumer chaos. I built my image. I'm not pushing it. You can push the image, but just make sure to refer to it as consumer chaos. Docker push, and your Docker Hub account and consumer chaos, just to move fast on this one. And before deploying, let's see the implementation. Now the consumer is having a peculiarity. We still have a web service we create. We create a new endpoint, the /consuming. And here I'm making a request to my provider. So if I open it a little bit on the right, you see I'm making a GET request within the consumer microservice in an HTTP URL, and then I'm defining some parameters, the URL and the port. These parameters are going to be defined in the YAML file of your deployment. So if I go to the deployment, you will see in the end, if you open it, there is an environment section for the spec, and we provide the provider URL, which is the provider chaos service. So what we're doing, we are making an API call from the consumer to the provider. And we are defining also the port that it's running outside of the load balancer. That's the only difference they have. And if you build it and pushed it, let's deploy it and see that it's actually working as expected. So, 1 second. So kubectl apply -f, service YAML, kubectl apply -f, the deployment YAML. And hopefully, if you run from your command line kubectl get service, you will see also the consumer chaos service up and running. All right? Now, I'm going to test also this as well. I'm going to run, 1 second, curl. Yes, I'm going to run this, the curl command, but now I'm pointing the new port, because this service, the consumer is running on 3002, not 3001, and /consuming, and what it's actually outputting, that the successfully consuming message, if you go to the main implementation, is the message that we are setting on the implementation of the service. So if I go here, in the successful, if we get 200 OK from the provider, just outputting a message, which is called successfully consuming message. And this is what you see here, and also on the command line, if you make an API call. It means that your consumer, it's also running, which is really great, but are we going to talk about chaos testing at all? Let's start with the chaos testing. Now, if you open provider, you see the chaos test JS, right? It has some things before continuing. I'm going to describe. This is the K6 API stuff you are going to see. We are using K6 on top. So it's good, of course, for people that they are using K6 to do chaos testing, to know a little bit fundamentals about K6 and how to do performance testing, maybe, or API functional testing. So here, we are importing some libraries. It's in JavaScript. We are importing the service disruptor, because this one will actually inject the failures, importing HTTP, and a library to do some validations. Now, we have 3 scenarios in the chaos test. The first scenario is the base. It's actually like a warm-up. It's not doing really fancy stuff. It's using an executor, which I'm not going to say a lot of things about executors and how K6 is working, but executor, it's the fundamental way how to say to the tool, K6, how to make API calls, right? So the constant arrival rate is, I'm saying that I want like a rate of 20 requests per second to be executed from the engine. I want to start with some virtual users. So the pre-allocated views are threads. I need you to go up to 100 and then stop, and that's it, and stop execution if you reach 100. And the exec is one function, just use one function to execute. We defined also some start time and duration. It's good if it's running indefinitely, you need to stop it. So the duration means that after 30 seconds, it may not reach 100 views, but I want to kill it, right? So that's important. We have the inject, which is the one that injecting the faults. If you see here, I'm using only one thread and one iteration. I'm not doing API calls, bombarding with API calls the service. I just want to do one, inject the faults within the pod and the service, and then stop. And I'm saying that the start time is 30 seconds. The good thing with K6 is that you can use start time to make tests run in parallel or sequential. So what we're doing here, we're running base without injecting faults, see what the latency is, the throughput of our backend APIs, do the injection of the faults, and the chaos scenario, which is the same as the base in terms of the rate of requests, etc. But we start from 30 seconds. So what we do is the injection and the chaos test run together after the warm-up. So the first time you are going to see 100% success rate on our backend API calls. When we do the injection, we expect the system to fail, right? And there are some thresholds. The thresholds are the SLOs. The thresholds are the SLOs, so are very basic, like request duration checks. I don't want to say a lot of things here. There are things to define, like if I get checks that are failing more than 90%, if I have success rate or failure rate of 10% or more, then I want to fail my test. This is the thresholds. And the main function of the request product. So the main function is just using the HTTP library to make an API call to my service, the consumer service, and then I'm checking if the response with 200. And the injection, you see here, I connect the service disruptor, inject my faults, and I rerun my test and see what's the outcome. Now, let's try to run this the first time. And I think we can slowly close a little bit. So go to the provider. The script is under the provider, but you need also to have downloaded the disruptor binary, right? So I have already my disruptor binary. In the README file in the beginning, just read the first lines. I think it's how to download disruptor. And this is the binary of the case 6 because we're going to use it, right? So, yeah, how much time do we have? I think I overspent time. Yes. Yes. How time do we have? We're a little bit bad. Kill me.
This one, when we run location blah, blah, blah,
It's a
I'm getting quote. Well,
quote.
yeah.
Yeah, because you need the, you didn't oh, what is that? Control C. Sorry, I think. It's not
So
up
if you
and running.
look, no, it's running. If you where is the kube
The other one?
get services. So if you look, I have.
This is the provider.
Yes.
This is the provider. It's not the consumer. You're hitting the consumer.
Okay.
So if you hit this connection, why is that? Did you run the Minikube tunnel?
Yes.
Where?
It's,
You shouldn't close the Minikube tunnel.
It's in another window. I put it here. So it's running.
It's running the
Yes.
provider.
But maybe I did just the consumer, just the provider and not the consumer. Is that
The consumer. This, okay, now I'm running my test, but I need to be a little bit, okay, to be more readable. So the test is running. You will see some stuff from case 6 like the chaos test. You see 3 scenarios, the base, the chaos, and the inject. This is the 20 iterations for 30 seconds. The chaos, the inject, and here, not very nice how it's being seen. We see that the inject being performed, and now we run the chaos. They didn't run in parallel, they run sequentially. So we run base, we run inject over here, and the chaos. It's taken some 30 seconds, I think, in total duration. Right. I get some failures, by the way. Give me 1 second to. By the way, I'm deleting. Sometimes you may delete the service if it doesn't have a connection, a correct connection. So you need to delete the services and rerun them again. So I will do this, apply, go to provider, apply the service, apply the deployment. Let's rerun the test. Oh, what's happened? Just a moment. Okay. Yeah. I had some connection issue, nothing serious. So I'm going to rerun it. if your environment sees some failures with the agent, I have seen that before in another conference, people ask me about it, just delete the deployment of the service and rerun the apply command. So I actually redeployed the microservices once again. There is an issue over there. I think it has to do with the Minikube version, but I haven't seen why. So now the chaos testing scenario is working as expected. So you will see that we don't have failures over here. And the chaos is executed. And it will finish, and we'll see that, what do we expect? We expect failure rate, right, in our tests. So let's see, finishing this. Nice. If I go on the top, yes, indeed, I see that there are 60 requests that are failed after I injected faults on my service. Great, so it's working. Injected faults, and I see I have a success rate of 95% on my backend APIs. Now, and before closing the workshop, just 1 minute to do a solution. So in the end, we can do solutions about this. So what I'm providing, down, a little bit down here. So what we provide as a solution, you can copy it. I think, Yannick, it's not showing well because we have the camera, but a solution is just to do a for loop, and when you get a 500 request about failure on your service, just to retry one more time. That's the solution here, you see. So I'm actually doing 5 retries in the for loop, making 5 times the API call. Why? Because I'm injecting 500 errors. So I'm injecting, but I have a recovery mechanism within the microservice. So let's do it. Let's have the solution and see that everything works as expected, and close up with the game very quickly. So what you need to do, go to your consumer. You need to open the main Go, copy everything there. We copy the new implementation from the README, all right? So then you need to go to the consumer and do the whole stuff again. So the first thing is delete the service from the cluster, all right? And the deployment. And for me, I have done this, but you should be doing that again. Let's run the build of the consumer. So we need to build a new image now, because we did changes on the main implementation. I need to build the image, push the image, the new image with the solution. Cool. I push the new image, great. And then we need just to run the service on the cluster with the solution. Just run apply, the service, run the deployment. Great. So we have deployed a new instance of the consumer service on the cluster. Let's go to provider and run the chaos test and see what happens. What do you expect, right? Shouldn't be 95%, should be less, maybe 100, maybe, because you did the recovery mechanism in your service. Let's see, it's interesting. Sometimes it's 99, it's not even 100, I don't know why. But the final point. Okay, the base run, they executed one VU, meaning one thread injected the faults within the microservice. Cool. The chaos scenario, now, okay, you see one request failed with a GET request, but it's normal. Some requests can fail on your backend APIs. It's completely normal. But we don't expect 95% success rate as before with the injected failures. Let's see how much we got. So the first thing to notice is that the thresholds violated, sometimes they are violated. Yes, indeed, we have 99 now with just a recovery solution of retrying multiple times the requests within your microservice. Just only one request failed, which is great. We increased our success rate. So with the chaos testing, this is all about chaos testing. You inject false to see how the system recovers. And it's running only, unfortunately, this tool, the Grafana K6, is running only for microservices running on a cluster. Right? If you don't have a Kubernetes, it's not going to be helpful for you. Cool, that's it. Before closing, I think we have time to play the game, the Kahoot, for the lucky winners. All right. So before playing the Kahoot, not share, present the viewer. Okay. So if you need more details, I'm going to do my sales pitch now. This, I think it's a coupon. I'm a Udemy instructor as well. I'm writing some nice courses in Udemy. So this one is for the chaos. I have created one, coupon for you for the meetup today. It's very cheap. I'm not saying if you want to take it. If not, that's completely fine. And maybe I can give some free also coupons for the meetup as well. Maybe we can do that later. Yeah. So let's play the game, right? No, just a moment. Have you used Kahoot, by the way? No? What the hell? Sorry. Okay. So I'm human. My God, so much security.
You are or not?
I'm a tester. I'm a functional tester. I'm not a security tester. Let's go to the Kahoot. Let me find the one that I know that I have been using. Here's a testing. Sorry guys, right. Start classic mode. I think you already know that. Just connect, scan it. What? Zoom. There will be a t-shirt from Grafana, stickers from Grafana, learning actors, goodies. I don't know what they are going to send, but what? Να, άμα κάνω zoom δεν με αφήνει. Okay. Go, go, go. There are pizzas, there are drinks, there are a lot of things. very quickly. Τελειώσουμε. Τελειώνουμε.
Δεν μπορώ να σε δω σήμερα, έχω δουλειά.
Θα φύγετε αύριο για κυνήγι.
Ναι.
Πότε να σας δω εγώ τώρα.
Κάτσε τώρα. Είναι η οικογένεια εδώ.
Ναι.
Θα έρθω εγώ να σου τώρα.
Τι θα έρθετε, όχι.
Αύριο το απόγευμα.
Αύριο το απόγευμα, ναι. Μπορείτε.
Άντε.
Να
χαιρετίσματα, θα
βρεθούμε
το δω
αύριο το απόγευμα.
Και στο ξενοδοχείο δεν έχει καφέ.
Ναι, πώς είναι.
Ένα καφέ εκεί πέρα στο λόγο.
Ναι, κύριε Μιχάλη, χάρηκα πολύ. Guys, okay. No. In the back, and the people in the back, they can play also. There are cool games. Just scan the code. Tell me when you are ready. Το πατάω. Εντάξει. Πάμε. T-shirt γραφάνα. Τσουτσούριασα. Το γράφουμε αυτό. Why reliability is hard. Έχει πολλές απαντήσεις, Οκ. Προχωράει μόνο του, έτσι δεν είναι. Για να δω. Εγώ Γιώργος ή Γιώργος, κάτι άλλο. Εσύ είσαι. Ωραίος. Adoption bar for chaos engineering is too high. Ερώτηση είναι αυτή, Παιδιά, μετράει και η ταχύτητα. Πρέπει να είστε γρήγοροι στις απαντήσεις. Να μην σας αγχώσω κιόλας. Οκ. Δεν περίμενα το false, να πω την αλήθεια. Όπα, DG. Ποιος είναι, ο καινούριος. Δημητρής. Διαμαντής. Πάμε. How the service disruptor works. Μας τα steps που είπαμε. Πρέπει να τα βάλετε στη σειρά. Με τι ξεκινάει και με τι τελειώνει. Λίγο δύσκολο αυτό, Και η μουσική είναι λίγο creepy, δεν ξέρω. Αγχωτική πολύ. Λες και παίζει τον εκατομμυριούχο είναι. Και είσαι σωστές όμως. Μια χαρά. Για να δούμε. Ρουνέριος. Ποιος είναι. Παιδιά. Όχι. Μπράβο. Εγώ χαίρομαι. Ιδιαίτερα. Which technique introduce errors to systems. Εύκολο. Πάμε αυτό, γρήγορα. Οκ, πιο πολύ σωστή, μπράβο. Τάσος, καινούριος. Παιδιά, για μια μπλούζα, μα είναι να πάω σας τυπώσω μια. Μην κονταροχτυπιέσαι τώρα, δηλαδή. Καλά, αυτό είναι Paul. Δεν κερδίζετε βαθμούς, νομίζω. How did you find the workshop? Αυτό είναι προσωπικό για μένα. Δεν θα πάρετε βαθμούς. Θα με πικείς. Θα σας δώσω κάποια στικεράκια μετά. Για να δούμε. Ωραία. Κάτσε να το χωνέψω λίγο πριν προχωρήσω παρακάτω. Μ' άρεσε το perfect, Ήσυχε λίγο. Το έχεις καβαλήσει το καλάμι. Λοιπόν, slider, άλλες 2 ερωτήσεις και τελειώνουμε. Double points. How many Chaos Monkey types Netflix has? Θυμάστε τώρα γίνει την ωραία οθόνη με τα πολλά. Βάλτε λίγο πάνω κάτω που πιστεύετε ότι είναι. Βάλατε εκεί κοντά στα θέα, όντως ήταν αρκετούτσικα ήτανε. 8. Για να δούμε. Ναι, μπράβο! Η Ελίνα πρέπει να είσαι εσύ, ναι, το κατάλαβα, είχες μια έτσι... Κι άλλο double points. How pod disruptor works. Έλα, εδώ το... Δύσκολο πάλι. Όλα τα δύσκολα στο τέλος τα αφήνω. Πέντε σωστές. Μία παραπάνω από την προηγούμενη. Μπράβο. Η Ελίνα πρώτη... Αμάν, Ελίνα, να μου πεις νουμεράκι για να ξέρω. Μπορεί να μην βγαίνει καλά τα μεγάλα νούμερα της γραφάνα. Λοιπόν, ένα τελευταίο. Δεν ξέρω αν είναι η Ελίνα πρώτη. Which are the principles of chaos testing? Και κλείνουμε πρωταθλητή. Πάμε. Είναι πολλά. Τέλεια. Τα δύο chaos στο Scode, είπαμε control chaos, shift right, όχι. Και πάμε να δούμε τον νικητή. By the way, και οι τρεις θα πάρουν πραγματάκια από την γραφάνα. Μην στεναχωριέστε. Όχι μόνο ο πρώτος. Ο Άλεξ Λουνέριος και... Ωραία. Σηκωθείτε να σας δούμε λίγο. Σηκωθείτε. Μπράβο. Ευχαριστώ πολύ που παρευρεθήκατε.